This video introduces shadows of boxes, but I urge you to look at the previous videos to best understand this. I'm going to briefly show you how to draw a box in 1-point and 2-point perspective. So for 1-point perspective, the box has true horizontal and vertical lines. Connect each corner of this box to a vanishing point on eye level. Then draw another square within the same converging lines. And if you connect these two together, you get the box. Now you can move this square over and it will be the same size. You can even move it up a little bit and it will retain its size. So you can put a square anywhere in the picture using one set of converging lines. The bird's eye view is looking down at the box so we see its top, and the worm's eye view is looking up so we see its bottom. In 2-point perspective, the box has true vertical lines but no true horizontal lines. Start with a point of space between the two vanishing points so that the angle here is greater than 90 degrees. Then determine where you want the front edge to be and connect both the top and the bottom to both vanishing points. Next, find the one side within these converging lines and connect it to the other vanishing point. And in this final case, find the right side and connect it to the left vanishing point. And you can see the back of the box goes from here to here. And it's important not to have line 2 on top of line 1 because they'll appear conflated. Here are 3 boxes in 2-point perspective. So they have true vertical lines but no true horizontal lines. Eye level is here, and this box is on eye level, so we only see 2 sides of the box. We're looking up at this box in a worm's eye view, and we're looking down at this box in a bird's eye view. Every corner is connected to both vanishing points, and it's important to identify this back corner, especially when we start getting into shadows. This is the simplest scenario where we have parallel light rays and horizontal shadow lines so that all these light triangles are proportionate to one another. In other words, they have the same height to width ratio. And to check your work, make sure all these lines converge toward the same vanishing point. But all these right triangles are tedious, and a more energetic approach is to have the shadow lines slant slightly, and outside they must slant in the same direction as the light, and also they have to slant upward because they're going toward the horizon. To find the shadow of a box, start with 2 vertical poles and find their shadows. Then connect the ends together and make the pole a rectangle, and you have a rectangle with its shadow. Then draw another vertical pole and find its shadow, and connect these two, color this in, turn this into a rectangle, and you have a box with its shadow. And notice that the only part of this box that you need is the shade line between the light and the shade, which goes up here, across the top, here, and down. In other words, the 2 red rectangles put together. The top of the box makes no difference. The easiest situation is when we're really just finding the shadow for an upright rectangle. And this occurs when the shadow line and the lines for the box line up together. The shadow ends up having 4 sides, 2 of which converge toward the vanishing point for the shadows, and 2 of them going this way converge with the horizontal pole. A slightly more complex shadow involves 3 vertical poles that we see. And you can see that the lines that go through the bottoms of these poles go to the vanishing point for the shadow, whereas the lines that don't touch the poles go to the vanishing points to the right and left. Now, slightly harder is when one of the poles is in the back of the box, so that we have to determine the actual structure of the box to find this back point here. And even harder is when we use front lighting and most of the shadow is behind the box. I drew 3 boxes using this light and this vanishing point for the shadows. In the first box, the light is side lighting the box, and the box is in 1-point perspective, so it has true horizontal and vertical lines. We end up then with 2 sides that go toward the vanishing point for the shadows, and only one side that goes to the vanishing point for the black box, because it only has one vanishing point. And the other side of the shadow is horizontal. And this is the only box that has a horizontal side shadow because it's the only one in 1-point perspective. And remember, you can't get horizontal lines in 2-point perspective. So let's next look at this purple box. It is also side lit, but it is in 2-point perspective. So now we have the 3 lines going to the vanishing point in the middle of this box here. And then we have one going to a purple vanishing point over there and one going to the other one over here. In other words, this vanishing point and this vanishing point. And finally, we have a box under the light. And it's unusual because all the vanishing points for the shadow go to the center of the box. And on the outside are sides that go to the green vanishing points on either side. Let's vary the position of the vertical reference line and see what happens to the shadow. It connects, remember, the light with the shadow vanishing point. So if we move it to the right, then the shadow goes to the left. And if we move it to the left, the shadow goes to the right. Now, if the light is low on the horizon like sunset, then the shadow is long. But if the sun is nearly overhead, then the shadow is short. If we look at the building using a high eye level, as if we were in a second-story window on the other side of the street looking at this building, we would see a relatively wide shadow. If, however, we were on the ground on street level looking at this building, so that eye level passes through the lower part of this building, the shadow is short. In this case, I want to draw a shadow of a pole onto this box. And in this first case, the shadow line and the line for the object go in the same direction. So it's just a matter of going up, across toward the shadow vanishing point, then down, and line 2 is really a continuation of line 1. Now, if the light triangle isn't parallel to the surface, as in the second case, then the shadow line hits the box, it goes vertically up, it follows the same direction, or you could go around the other way where you go to the back of the box and up, and where these lines hit the light ray is the end of the shadow. Now, if you want to have a new vanishing point on this vertical reference line to use for the top of this box, draw a line from the first vanishing point to the end of the end of the box, then up and back, and continue it until it goes to the vertical reference line. And that will be your new vanishing point that you can use, for example, for this shadow. This is front lighting to find the shadow of a rectangle. So the pseudo-sun is down here, and the light rays go down to the pseudo-sun. The vanishing point for shadows is on eye level, and you can see all these lines go to that vanishing point. So this shadow line is not parallel to the box. It goes vertically up and then across to the shadow vanishing point and down, and where it intersects the light is the end of the shadow. To find the shadow on this wedge, I started with a horizontal shadow direction that goes to the end of the wedge and then up, and the line here has to attach to the point where it enters the wedge. And in that way, we can find the end of the shadow. In this case, the shadow direction is slightly angled and the light is higher, so that part of the shadow of the pole is on the ground. And here I did the same kind of construction except with a freeform object. To find the shadow of this pole on this box, I chose a horizontal shadow direction. It goes vertically up across the box down until it intersects the light. In the second case, the shadow direction does not align with the box, so you have to find the back of the box here, go vertically up, across, down until it intersects the light. In this third case, you have to use the shadow direction under the box to find point 3, and then vertically up so you know where 2 is located. And even though this is a diagonal, it looks like all of these lines are on the same plane. For this complex form, find the shade line that divides shade and light. So one part of it would be here with the shade here and the light here. It would then continue up here, across, and on top of the building and down. And both ends of the shade line connect to the shadow here and here. So you can put poles with tops anywhere along the shade line to find the light triangles, and only use the ones that make a difference. For example, you could put a pole right here, but its light triangle wouldn't change the shadow. Extending the surface can be a useful technique. How, for example, can we find point B here? We need to draw this light triangle, so we have to extend this green surface to do so. And where the shadow line crosses the edge of the structure is point B. Then it goes vertically down, following the vertical casting surface, and then it goes to the nearest corner. In the second case, we're trying to find this shadow right here. So the shadow starts at number 1, goes toward the shadow vanishing point. When it hits the light, it travels in the same direction as the horizontal pole. And when it gets to this blue wall, we want to complete the light triangle to find point 4 here, and that will give us the angle of this shadow. I drew the shadows of 4 boxes using light here and the vanishing point for the shadows down here. And I want to concentrate on this last box. So we have pole 1 that creates a horizontal converging shadow to the wall, and then a vertical shadow up. And we know it's from this vertical pole because the light triangle connects the two. Then we have pole 2, which is a horizontal pole, and it casts a diagonal shadow on the wall. And then finally we have this horizontal converging pole here, which casts a horizontal converging shadow on the wall. For this image, the base of this vertical box is right here, behind the base of the flat box. To find the shadow, draw shadow lines through the left back corner and the front right corner, going in this direction. We don't know where the shadow ends because it hasn't yet met its light rays. When we finish the shadow, you can see that the shadow on the box is much thinner than the one on the ground because it's closer to eye level. And at eye level, all shadows are lines. And again, we have any shadows that go underneath vertical poles go toward the shadow direction, even this one, which goes under the vertical pole of the vertical box. Here is a summary of elements that affect shadows. My next video will talk about boxes in the air and against the wall.